In this video, I'm going to review a strategy for solving more difficult word problems where we're going to start with the answers. So the steps to using a guess and check strategy is to first read the problem carefully and understand and note the relationships in the problem. We need to know that in order to take step two. Then we're going to work backwards from each possible answer using these relationships. If we're successful, one of those possible answers is going to reveal itself as being the correct one because it's the only one that will agree with the statement in the problem. That probably sounds kind of confusing at this point. Hopefully, it will make more sense after we go through 4 examples. I want to talk about a very common useful relationship that you can take advantage of in problems like this. We have a known total and we subtract a known number, and that will give us the other number. For example, if we know that we have 25 coins in our pocket and we're guessing that 10 of those coins are pennies, and we know that the other coins are nickels, we can say 25 coins minus 10 pennies, there must be 15 nickels. So we know the total, we know the quantity of one item, we can figure out the quantity of the other item. Very useful. For example, this is something that will probably you'll answer very quickly. 3 people go to the movies and 2 of them are kids. How many are adults? Well, you're probably answered 1 pretty quickly, but we're using the same principle. We know there were 3 people. We know that 2 of them were kids. So the rest must be adults. You'll be surprised at how often you can make use of that simple idea in word problems. Here's some problem types where this can be very helpful. Problems involving 2 kinds of tickets, adult tickets and children's tickets. 2 kinds of coins or bills, like the example I gave a moment ago. 2 items with different weights. Buying 2 different kinds of things, say pants and shirts. You'll recognize these problems when you see them later. This first example I have is a little bit different than that common principle that I was just talking about. This is a consecutive number problem. It's similar, but a little bit different. We're told that 3 consecutive numbers total 153. What is the first of the 3 numbers? Well, these are all possible answers for the first number. If we know the first number, then we know the next 2, right? This must be 53 and 54. And after 51, we would have 52 and 53. 50, 51, 52. And 48, 49, and 50. Those are 3 sets of consecutive numbers. Only one of them is going to add up to 153. So we add them up. This one, I've already added these up, so I will reveal the answer here. 159, 156, 153, and 147. We don't have to add them all up. We just have to add them up until we get the one that matches what we were looking for. So a very quick way of solving 3 consecutive number problems if you are given 4 possible answers to work with. All right, example 2. Stan has $1 and $5 bills in his pocket. There are a total of 10 bills in his pocket. If he has a total of $34 in his pocket, how many $5 bills does he have? So we always want to pay a lot of attention to this last statement because that tells us what this guess is all about. These are guesses that we're making. 3, 4, 5, and 6. one of those numbers is correct. Now, keep in mind that if we know the number of fives, we can figure out the number of ones. This is where that principle comes in. We know that between these two, there are 10. So we can use subtraction. 10 minus 3, 7. 10 minus 4, 6. 10 minus 5, 5. And 10 minus 6, 4. Notice that all of these add up to 10. They have to, because there are 10 bills in the pocket. Now we can take advantage of our knowledge of how money works. We're going to multiply the $5 bills, the number of $5 bills, by 5. Like that. And we can just add that to the number of $1 bills. We don't have to multiply that by 1 because that's not going to change anything. And we add this up. So our addition would lead to 3 times 5 plus 7 would be 22. 4 times 5 plus 6 would be 26. 5 times 5 plus 5 would be 30. And 6 times 5 plus 4 would be 34. Again, I'm doing this quickly to try to keep the video short. If you want to go back and rewatch part of this, go ahead and do that. And we're looking for the one that totals $34. So sure enough, this very last option totals $34. So we know that the answer must be D6. Going on to the next example. Kat bought 8 tickets to a play for a total of $49. Adult tickets were $8 and tickets for children were $5. How many tickets were purchased for children? So she bought a total of 8 tickets. So our guesses are for children's tickets. And 4, 5, 6, and 7. I'm rewriting this because it makes it a little bit easier to do the math after we figure out the quantities. So now we're going to do our adult tickets, and we know that there were a total of 8. So we're just going to subtract. 8 minus 4 is 4. 8 minus 5 is 3. 8 minus 6 is 2. And 8 minus 7 is 1. Now, unlike the problem with the money, here we have to use the price that we're given for the tickets. Children's tickets are going to be times $5, and adult tickets are going to be times $8. So 4 times 5 plus 4 times 8 will give us the amount that would have cost. Keeping in mind that only one of these is going to be right. You don't have to sketch all of these out like I am. I'm doing that for demonstration purposes. Now we want to do the math and figure out what these totals would have been. 4 times 5 is 20, plus 4 times 8 is another 32. That would have been $52. Close, but not quite. 5 times 5 is 25, plus 3 times 8 is 24. That is $49. And we just found our answer. We could do the other two if we just wanted to double check that we didn't make a mistake here, but we can feel comfortable that the answer must be 5 children's tickets. All right, one more example. This one's a little bit different. This one involves age. Laura is 2 years more than twice as old as her brother John. Their ages totaled together total 20. How old is her brother John? So it's always really important to pay attention to this last statement and realize that these numbers that are the answers or the possible answers are an answer for the age of John. And what we would really like to know is how old Lara is. Now, this is where we have to use the logic in this problem. She is 2 years more than twice as old as John. So if you remember when we were doing translation, 2 years more than twice as old would be 2x plus 2. Twice as old plus 2 years. So what we're going to want to do is apply that here. We're going to take John's age, multiply it by 2, and then add 2. So 6 times 2 plus 2, that would be 12 plus 2, 14. 7 times 2 plus 2 would be 16. You see the pattern here. 8 times 2 is 16, plus 2 is 18. And 9 plus 2, or times 2, is 18 plus 2 would be 20. Now, what we're looking for is their ages total added together, total 20. So let's add these two together. 16 plus 14. 6 plus 14 equals 20. Their ages added together is 20. So we're done. We can show that these other ones don't give us the correct answer. Here, they're added together would be 23. These added together would be 26. And these added together would be 29. Only one of these can work. And that tells us that John must be 6 years old. Lara must be 14 years old. And their ages added together total 20. Everything works. All right, I know that was very quick. As I said, feel free to go back, stop the video, try to follow along. And then when you're ready, go and do the practice problems that will help you try to do these kind of problems on your own. Good luck.